Hello everyone. Welcome to this session on building IoT applications with IBM Watson. If you're attending this session for the first time, welcome to this series. This is sponsored by IBM. My name is Janakiram. I am an analyst, advisor, and architect, and I'm going to bring you sessions on cutting-edge technologies including containers, microservices, edge computing, and of course, Internet of Things. So in this session, I'm going to walk you through how to develop your first connected devices application. So this session has a few components. I'm going to introduce what is Internet of Things, followed by an end-to-end demo where I'll cover everything from signing up with IBM Watson, that is on IBM Cloud, and connecting your first device and building an application to control that. So this is going to be an interesting session, so stay tuned. I have quite a few things to cover today. So before I go any further, I want to make sure you are able to hear me fine and also you are able to see my screen. So if you have any issues with the audio or the quality of the video, do drop a note in the questions window and I will come back to you if there is any response or if there is any resolution to the issue that you're facing. So I also want to make sure you're actually able to see my screen. So if you're able to see this, you would notice I have live devices. I have a couple of Raspberry Pis connected to a few sensors, an actuator, and an LED. So as you can notice, this is going to be a live demo, which will include configuring Raspberry Pis and connecting them to the cloud. So I got a feedback that audio and video are good. So thanks for that. And we are all set to get started. All right. So what exactly is IoT and where we are today? Well, Internet of Things is not really new. It's been around for quite some time. I would actually say IoT has been around for more than 20 years. The thing is, we never called that as Internet of Things, but we have been connecting a variety of devices to computers and started to control them, started to acquire the data coming from them. If we go back in time and look at IoT in 2010, we had just a few devices that were connected. For example, our smart thermostats, smart scales, some of the connected devices, including our printers, media players, all of them were actually gadgets or devices that were connected and were controlled from software, and they could actually talk to each other. And today, when we look at where we are, it's very common for us to go around with a wearable. It could be your fitness tracker or a heartbeat tracker with a Bluetooth headphone and your of course your smartphone. And if you actually notice, all of them are interconnected. For example, when I wear Bluetooth headset, I can control the audio of my phone from my watch. So it's sometimes pretty amusing to see how one device is actually orchestrating quite a bit of workflow. So it all started from there, and that is where we are. But if we actually look at the IoT in 2017, it's kind of exploding. Today we are dealing with many devices. We have voice assistants like Amazon Echo, Google Home, Cortana, Siri, and so on. And then we have a variety of devices that are increasingly getting connected. So by 2020, we'll see an explosion which is going to further increase the usage of connected devices. So we are just at the beginning, and as we go forward, we'll notice that almost every device that we use on a day-to-day basis is going to have some kind of connectivity. It will start sending data for us to track. It can be controlled from your mobile phones and your PCs, and one device can talk to other. For example, your car will be able to notify your air conditioner that you are just a few kilometers away from home, and it is time to switch on the air conditioner to keep the room cool. So this is not going to be very fictitious or very forward-looking. It's going to be a reality very soon. So get ready to experience an explosion of devices and connected applications. So if that is IoT, what's in it for enterprise? What's in it for developers? Well, I want to spend a minute walking you through the current state of enterprise IoT. So the difference between consumer IoT and enterprise IoT is the scale. So consumer IoT typically deals with a bunch of devices, a handful of devices, and they are primarily focused on controlling and sending commands. For example, can you switch off your geyser from your mobile phone? Can you turn on a bulb in the living room from your bedroom? So those are the use cases for consumer IoT. But when it comes to enterprise IoT, it is going to be number one, scale. Number two, dealing with a lot of data. So connected vehicle is going to be an important scenario. We'll actually notice that most of the vehicles would have some kind of connectivity. So a company that is manufacturing tens of thousands of vehicles and selling them, it manufactures more, but it sells tens of thousands of vehicles in each country, and those vehicles are going to be always connected. And similarly, a large manufacturing company is going to turn every equipment into some kind of a connected device, and it is going to stream a lot of data. So enterprise IoT is all about scaling the number of devices that are connected to the platform, and also dealing with a deluge of data. So the data that is coming from multiple sites, multiple machinery, multiple equipments, and multiple users, social media, how do you correlate all of them and start to make insights? That is primarily the goal of enterprise IoT. And if you look at the big picture of enterprise IoT, there are remote assets. These could be smart factories, smart buildings, smart cities, connected vehicles. It could be any of those devices that are always connected to the IoT platform. And on the other end of the spectrum, you'd actually notice there is user experience, and the user experience is predominantly driven by business intelligence. For example, if I am the operations head of a company and I am measured on the efficiency, I would like to see a dashboard that tells me the health and the state of all my factories distributed across the country. So I want to zoom into a specific site, understand how it is performing, what is the energy efficiency, what is the production capability, all of that using one single dashboard. Now, this can be extrapolated and this can be utilized for predictive analytics. For example, I'll be able to predict how my production would get impacted by a variety of scenarios in the next 6 months. So traditional business intelligence and data warehousing combined with IoT will deliver tremendous insights to CIOs and CXOs. Then, of course, floor managers, supervisors, and operations professionals can control devices remotely. So there is a command and control operation that is going to be performed from the user experience. For example, turning on a remote equipment or adjusting the RPM of a turbine fan, changing the temperature of a furnace, all of those can be performed using a mobile phone or a wearable or a web front end, which will control the remote device. And finally, there is going to be an administrative and management module that's going to onboard devices, onboard users, define roles, define role-based access control. The usual management layer is going to be an integral part of IoT. So in between the user experience layer and the connectivity, which is the devices layer, we have the actual platform. Think of this as the middleware that connects the applications with the devices. And when we zoom into that, we notice that there is something called device registry, and think of this as the repository of device definitions. If you're familiar with Active Directory, which stores the user database, think of the device registry as the Active Directory of devices. Primarily, every device that is connected to the platform will have to exist in the device registry. So it is the central repository of device manifest, their metadata, their state, everything is going to be stored inside the device registry. And this has to be extremely scalable to support the ongoing growth of a variety of devices. Once the devices are registered with the registry, then they'll start sending data. So the data is also going to be of high velocity and high throughput. For example, certain sensors connected to these devices will send data as frequent as once in 10 seconds and 20 seconds and so on. So if you have a few tens of thousands of devices sending this data every few seconds, you need to manage that very effectively. So you need a data ingestion layer that is going to acquire the data coming from a variety of devices at a very high velocity. So the metadata that is stored in device registry and the streaming data that is coming via the data ingestion layer would go into the message routing policies rules engine. Think of it more like a rules engine, which will define how these messages are going to be delivered. For example, they will be stored in a relational database if it is structured data. It will be stored in object storage if it is unstructured data. For example, if the devices are CCTV cameras, you would want to store the output of your camera in object storage. If the data is coming as time series data, you would want to store it in a time series database. Irrespective of how you store it, it is going to be primarily stored in a database. And there are multiple types of database that could be used for IoT deployments. Apart from that, there are certain metrics that need to be tracked in real time. For example, in a connected vehicle scenario, you would want to find out the driving pattern in real time. If the vehicle is throttled too much, if there is an unusual braking, or if there is a violation of the speed limit, you want to track that immediately. You want to send an alert back to the driver or to the vehicle service center about the unusual pattern that you are detecting in the vehicle. So those metrics will go into what is called as stream analytics, and this is where a real-time analysis of data would be done and immediate decisions would be taken. Apart from that, there are certain data points that will make sense over a period of time. For example, the mileage of a vehicle, there's no point in tracking it in real time because the efficiency, the mileage of a vehicle will be defined only after you have sufficient data. So data points related to fuel consumption, for example, would be sent to batch processing. And this is where we'll have Hadoop clusters and Spark clusters processing data over a period of time, and they'll deal with historical trend analysis, which will make more sense with time. So that is batch processing. And then there is machine learning, which is a newer component. It's more recent addition to this stack, and this is going to deal with data coming from all these sources, and it will perform predictive analytics. For example, are there anomalies in the incoming data? And if there are anomalies, what kind of a fault code would it point to, and what kind of an action should be taken? So that is going to be determined by the machine learning algorithm. And this will come back with very interesting predictions, like what is the remaining useful life of the device, what are the probable faults that this device will demonstrate or show in the next few days, and what kind of impact it would have in your production. So all of those forward-looking predictions will be handled by the machine learning component. So this is the big picture. Of course, there are many other components, but at a high level, this is the big picture of IoT. So let's spend some time on each of them. Devices, these are the most important components of the IoT solution. Devices can be largely classified into three. There are IP capable devices, which can directly connect to the platform. They actually run a TCP/IP stack within their software and firmware, and they can make an outbound internet connection. There could be non-IP capable devices, predominantly running a memory constrained and power constrained a microcontroller and devices, and they can only talk Zigbee, Bluetooth Low Energy, Z-Wave, or Power over Ethernet. They are not capable of making a TCP/IP connection to the outside world. And then we have legacy devices, and these legacy devices have been around for a couple of decades, and they use very traditional protocols like SCADA, RTU, PLC, and traditional telemetry. So these are the type of devices that we can onboard to an IoT solution. And then there is a gateway, and gateway can be classified into two types. One is called the field gateway, and the field gateway, for all practical purposes, is like any other device. And this device is actually proxying a set of non-IP devices, and it represents them to the cloud platform. For example, if there is a tiny thermostat and it doesn't run a TCP/IP stack, it talks to the field gateway, and the field gateway would represent all the thermostats running in that floor to the cloud platform, to the IoT platform. So if you want to control one of the thermostats, you would actually talk to the proxy, which is the field gateway, and that would communicate with the thermostat. And this communication is not going to be on TCP/IP, but it would be essentially Zigbee or Z-Wave or any of the low-range protocols. The counterpart of the field gateway is called the cloud gateway, and that is going to reside in the cloud, and that's the endpoint, or that's the gateway, that is the primary entry point for the devices to get authenticated, to get authorized, and to actually make a handshake with the cloud platform. So these two endpoints, the field gateway and the device gateway, they are responsible for establishing the connection. They are responsible for enabling publishing of messages and subscription of the messages to the topics that are exposed using protocols like MQTT. And they also manage the device to cloud messages that are flowing from the devices towards the IoT platform, and the commands that are sent from the IoT platform back to the devices, and they are called C2D, cloud to devices, and the messages that flow from devices to cloud is called D2C. And typically the gateways can talk HTTP, MQTT, AMQP, and WebSockets to the outside world, and internally they would use a variety of protocols that are compatible with the legacy devices and the non-IP devices. Coming to the data ingestion part of the stack, so ingestion endpoints are slightly different from device management endpoint. They are typically exposed to ingest data at high speed, high velocity. And if you are familiar with the technologies like Apache Kafka, it's actually a data ingestion product. It's an open source project primarily designed for streaming. So if you are using a non-unmanaged IoT platform and you're assembling a stack, there are a lot of chances that you would actually end up using Apache Kafka for data ingestion. And it enables one-way communication between the devices and platform, because it's only the telemetry that flows from the devices to the cloud. Storage, as I mentioned, every message, every log, every event generated by the devices is going to be stored in the platform. The raw data is going to be stored in data lakes and object storage. Structured data will go into relational databases, and time series data goes into a NoSQL database optimized for time series. Again, mapping them to a set of products and open source projects. Object storage, obviously it is Minio if you're using open source, or Amazon S3, Azure Storage, IBM Object Storage, and so on. And if you're using relational databases, the usual suspects are MySQL, DB2, Microsoft SQL Server, Oracle, Postgres, and so on. For NoSQL, the most popular one used for IoT is going to be a combination of InfluxDB and ElkStack. Both of them are capable of tackling the time series database that comes with a timestamp attached, and the Elk stack, which is the Elasticsearch, Logstash, and Kibana, takes care of textual and unstructured logs, unstructured textual telemetry. So those are going to be first stored and then processed. And the process data is also come back and get stored in one of these data sources. And the storage is exposed to the outside world as a REST API, because that is how you would pull the data sets for integrating with data warehouses and business intelligence. Coming to hot path analytics, hot path analytics is the route that critical messages go through. And this is where I was explaining how you would want to monitor the data points that are critical to be monitored in real time. For example, the vehicle metrics related to fuel level, the brake oil level, the engine temperature, the throttling, braking, and the RPM. Now, all those metrics are going to be monitored in real time, and they go through what is called hot path analytics. And hot path analytics are typically implemented using Apache Storm and Apache Spark. Either a combination of these technologies, or it could be an independent service like IBM Message Hub, talking to IBM InfoSphere, which is capable of performing the hot path analytics. In case of Azure, it's going to be Azure Stream Analytics combined with Azure Event Hub. Kinesis, if you're familiar with Amazon, all of them implement hot path analytics in a managed form for the customer. They're also capable of invoking third-party web services, for example, invoking machine learning models exposed as web services, or exposing the endpoints related to geofencing and location API that can be integrated will make a lot of sense for hot path analytics. Cold path analytics delivers insights collected from data over a period of time. It's not going to give any insight, if you ingest data in real time and wait for it to come back with some insights or dashboard, because batch processing, which is also called cold path analytics, will only make sense when you collect data and process it over a period of time. So the more data you have, the better the insights are. That's where you'll use MapReduce, which is based on Hadoop, or you would use Apache Spark for actually performing MapReduce in batches. And that's going to be much faster. And when combined with the hot path analytics and the other reference data that comes from your master database, cold path analytics will give you a lot of insights that will help operations professionals in making very informed decisions. And finally, the application. As I mentioned, applications will consist of business intelligence delivered via very interactive dashboards. The application is also responsible for command and control, where you can send commands back to the devices and control them. And finally, you can define the rules, you can onboard users, you can define roles, all the permissions, managing the life cycle of users, roles, devices, and everything. So that's going to be handled through the applications layer. So to summarize, this is how we visualize the IoT stack. We have devices on one end, the applications on the other end, the user experience, and the IoT platform is going to be the middleware that basically connects the dots to ensure that we have a highly connected application. So that's the background of how the IoT applications are evolving and how we architect. I can't wait to show you a live demo. This webinar is actually split into two parts. This is the first part where I'll show you the device management, and in the next part, which is going to be scheduled for next month, we'll cover the data side of the things. So this demo will show you everything that you need to understand about getting started with Watson IoT, and how you would actually connect the applications back to the devices and start controlling them. So let me switch to my demo. Okay, so I start from the blank slate. I go to the IBM Cloud Console. Okay, so I'm already signed in. If you are not familiar with IBM Cloud, this is how you'll actually see your console. I just have one predefined application. We'll leave that as it is, but I'll show you how to define your very first application. So this is the IBM Cloud dashboard, and when you click on the navigation bar here, you will notice a variety of services, from application services to blockchain to a variety of things, and we are interested in Internet of Things. So I select this and it takes me to the IoT service dashboard. So I click on this, and this is where we'll actually select the core IoT platform. There are many other third-party services and some of the native services, but we are interested in building a simple application based on the core IoT platform. So we'll select the first one, Internet of Things platform, and this is going to show us the service. So let me call this TikTok. That is the name of the service that I am giving. And we can basically launch this in US South, Germany, or UK. These are the three regions where IoT is offered. Because we are actually using Cloud Foundry, and if you're familiar with the Cloud Foundry concepts, you always need to have an organization defined. It's like the namespace. So it's already defined here, and you need a space, which is primarily for dev, test, production, some kind of an isolation for you to have differentiated environments when you're developing and deploying applications. So the default space is dev. That's all. And I'm choosing the free plan, which is called the Lite. It's available to anyone. You can go ahead and sign up, and you can pretty much repeat all these steps. So That's all I need to do. Choose the region, give a name, and click on create. And this is going to just take a minute, and very soon we'll end up seeing the actual service getting created. So there we go. So now we have the TikTok IoT application that is getting created. And this is just the starting point. So I need to launch the dashboard by clicking on the launch button. And this is going to take us into the customized instance that is set up for us to start connecting our devices and building our applications. So let's wait for this to load. We are going to see a few options here. All right. So it starts with this default interface where we can actually see some boards. I noticed this has issues with Safari browser. This is slightly faster if you switch to Chrome. But nevertheless, this is going to come up in just a couple of minutes, maybe. Okay, so I'll come back to the card section in a moment, but the very first thing that we're going to do is to onboard our devices. Now, on the navigation bar, you'll notice that there are boards, which is the dashboard. Then there are devices, members, obviously the users, apps that you create, the mobile apps, web apps, and the APIs. You can track usage. You can also define rules. There is security, and of course, some mundane settings and third-party extensions. So let's get started with the devices part of it. Now, before you go ahead and add any devices, you need to have the device definition, and that is available through what is called as the device types. So a device type is like a class, and a device is like an object. And the device type would carry the manifest and the definition of the devices that we're going to onboard. For example, if we're going to onboard 1,000 connected cars, we need to have a definition of the connected car. We need to define what is the default make, model, and some additional metadata, and what kind of schema it's going to ingest. So it is going to basically become the template for the devices that we are going to onboard. So I'm going ahead and defining 3 device types. And a device could be a standalone device, or it can be a gateway. And as I mentioned earlier, the gateway itself is the it's like a super device that is capable of talking to many other devices behind the scenes. But for now, I want to keep this simple. So we are going to onboard devices right away, because I'm using Raspberry Pi Model 3 capable of Wi-Fi. So I can directly go ahead and onboard them. So first thing that I'm going to do is onboard a device type called sensors. So this is going to ingest data. So I will give the name of my device type as sensors. And here you can optionally enter some standard metadata that is going to be common for all your devices. Now, I just want to give the location. I don't have anything else to add, but you can add custom key value pairs as metadata and click on done. So now our very first device type is created. Since we are in this screen, I'll also go ahead and define another type called buttons. I want to actually have push buttons that are onboarded. So I'm going to create a new device type called buttons. Again, the only thing that I'm going to give is the location, which is Hyderabad, and we are done with the second type. And finally, I'm going to add some bulbs. So I'm going to create a few bulbs. So I'll define the device type as bulbs. Click on next, and we are done. So now, when we actually look at this, so we created the device types for sensors capable of sending some telemetry data, buttons that will send some commands, bulbs that will have some state. So bulbs will have state like on and off, buttons will send commands like, again, on and off, that will ultimately control bulbs. Sensors will send one-way messages about temperature, humidity, and so on. So with the device types in place, I need to go ahead and create the devices itself. So let's go back to the devices dashboard, and now we are going to create the device. So the first device that I want to create and onboard is a temperature sensor. So that is like the hello world of IoT. So I onboard a device whose device ID is temperature sensor. Click on next, leave all the defaults. We don't need to do anything. And here you need to either choose a token. A token is very essential for the device to get connected. So if you don't give a token here, you will receive a default token which will contain 18 characters. So it's always better to generate automatically, because it will create a very sophisticated token that we can use, but you need to make sure you save that immediately, otherwise that will not be shown again. So you'll have to drop the device and recreate all over again. So once we create the device by clicking done, this is going to generate the authentication token. And this authentication token is absolutely important for us to basically connect the device. So I have saved this. What I'm going to do is I'll put this in my editor just to make sure we have the key for this sensor before we lose. So I copied and pasted that in my editor, and the device temperature sensor is now created. So with this in place, we need to go ahead and onboard our very first device. But before we do anything further, we need to tweak some security settings. So the connection security of Watson by default uses TLS with token authentication. It's better to use TLS optional to start with, because this will not impose a lot of restrictions, and it is easy to connect non-secure devices. So that is one of the things that I'm going to perform. I'll change my settings to TLS optional and save this. So this is a global setting, so every device can just use the token that we have created to connect to the IoT platform. Now we can look at the state of this device called temperature sensor, and currently it is disconnected. Obviously it doesn't have any events, doesn't have any state, there are no logs, everything is blank at this point. Now it's time for us to connect our very first device to Watson IoT. So now I want to give you a quick introduction to the setup that we have here. So you'll actually notice that I have two Raspberry Pis. So this Raspberry Pi is connected with a button which will onboard in the next step. This is a button, it's a toggle button. You can switch on and switch off. This is actually the temperature and the humidity sensor. And you see another Raspberry Pi there with a red LED, and that's going to be the prototype for our bulbs device. And both of them are completely independent. They are connected to independent power sources, the power banks that you see there, and they are connected to the internet over the Wi-Fi. And if you are wondering what is this, this is basically called as a Grow Pi Plus, which is a very nice way for us to add sensors, actuators, and bulbs to Raspberry Pi. It just makes it easy to bring the Grow family into Raspberry Pi. So that's all I did. No more modifications. It is basically the setup that we have here. And now our goal is to grab this temperature sensor and configure it so that it can start streaming the live temperature and humidity to the cloud. All right. So let me switch to the command line. And here I'm going to SSH into my device, right? And here we are going to update a very simple Python script. And since I'm using Vim and it is not very convenient to explore this, I'll switch to my favorite editor and I'll show you what we actually do. So if you're familiar with MQTT, I'm actually using the standard MQTT library called Tahoe. And I need to populate some Watson specific parameters, and I have already created variables for all of them. For example, the host, which is going to be the endpoint of our IoT platform. And how do we get this? Well, the moment you created your IoT platform application, you'll actually notice that you are given a unique application ID. So if you actually go to settings, you'll notice that this random string, in our case it is RWX84H. When you append that to messaging.internetofthings.ibmcloud.com, you will end up getting the host ID. So this is going to be the MQTT endpoint listening on 1883. And similarly, you need to create a very unique client ID, and the client ID contains D colon the same ID, the application ID, followed by the device type, followed by the actual device that we created. And then the username for MQTT is always going to be use token auth, and the password is going to be what we just created when we onboarded the device. And the topic can be anything as long as it actually uses this format. IBM restricts how you publish messages to an MQTT topic. So here you have IoT2/EVT followed by the topic name and the format. Because I'm going to send JSON, I'll use this as JSON. And after that, we are basically saying that the humidity and temperature sensor is connected to the pin 7. And then we go ahead and open the MQTT client with the username and password unique to our device. And then we go ahead and connect with the IoT platform. And after that, we start an infinite loop where we basically grab the temperature and the humidity and publish that to our topic. That's it. And because we are doing this continuously, we use client.loop. And when we actually hit Control-C, we disconnect. So it is pretty simple. Now I need to go ahead and populate the real values in my Raspberry Pi. So the very first thing is the host. So I need to grab this from my organization ID, and put it here. And then the client ID is going to be this. So D colon followed by the organization ID, followed by sensors. This is the device type that we created, followed by temperature sensor. This is the actual device name. And then you always use this username, use token auth. It's actually an instruction to IBM Watson that you are using username and password and not anything else. And here we need to put the actual token that we grabbed during the device creation, and that is pasted here. So I'll grab this and put it here. That's it. Everything else remains the same. I just modified the organization ID, the device token, and of course I pre-populated this because I knew I'm going to use the same convention. That's about it. Now everything else remains the same. It's time for me to save this and launch my temperature sensor. So when I actually hit Python temperature.py, it's going to, so this is basically the temperature. It is 26 degrees Celsius and 33% is the humidity. So that's about connecting our device, and now we are actually publishing the messages. So let's come back to the devices section and we'll actually see a green dot. So if you notice, the green dot indicates that the device is live. And now when I click on the temperature sensor, it says connected. And I straight away go to logs, and this says token auth succeeded. If you're not able to see this, I'll increase the zoom. So the token auth succeeded. This is the client IP. This is the client ID. Fantastic. Now I actually come to recent events, and you'll start seeing the live data flowing in. So the temperature is 26 degrees, humidity is 33%, and this is live. And we just connected our very first device to IBM Watson IoT platform. Very simple, right? Now, as I mentioned, this is the first part of the two-part series. In the next part, I'll actually show you what we can do with this data. All right, now that the data is streaming, I want to take you to the next part. So let's make this slightly more interesting. So you'll actually notice that in my setup, I have a toggle switch, right? And this switch can be turned on or off very easily. Our goal is to control the LED that you see there. There is a red LED that you are seeing. I want to now go ahead and create a very simple app. When I actually turn on the switch, the toggle switch, it should control the remote bulb. So let's go ahead and finish those steps. And again, you'll not be overwhelmed. This is how you start building applications. Think of this as the Hello World app on IBM Watson. All right, so we are still streaming the data from the temperature sensor to the platform. Let's leave this as it is. Come back to devices. And it's time for us to create our two devices, the button and bulb. And remember, we already created the device types. So now I click on add device. And when I click on add device, I choose the type of my device as buttons, and I give the name of my device as button, right? It's a nice convention. It's almost like for each button in buttons, button dot on off, right? So it's easy if you're a developer to have this convention. So I go ahead, no metadata to be added. I'll click on next. I want this to generate a default authentication token. Let's click on done, and I'm going to grab this token. Very important, because if I miss this, I have to do this process all over again. So I'm going to paste this here just for reference. Perfect. That's it. Now the button device is created, but obviously it is not connected yet. We are yet to configure. Let's also go ahead and create the bulb type, bulb device. So bulbs, and I'm going to create a device called bulb. Next, and let's grab the authentication token. All right, so we have the token for our third device type, which is the bulb. That's it. Now we have everything that we need. It's time for me to get started configuring the button and bulb. I'm going to do it one shot. So let's stop the temperature sensor for a while and open button.py. It's exactly the same code. It's not very different, except that instead of sending the temperature and humidity data, I send the state of the button, and this button can be either on or off. So I'm sending a JSON payload that represents the current state as on or off. Pretty cool. So let's go ahead and finish this customization. So I want to change the org ID and use what IBM gave me when I created my workspace. And this is going to be buttons, button. This is the device ID, and this is the device. And now we are going to populate the actual token that we got for the button, which I have saved here. So let's grab this, paste it here. And the topic that I'm going to publish the button state is obviously going to be called as button. And since I'm using JSON, I'm using fmt/JSON. This can be CSV, this can be plain text, but you can't send binary, at least not in this format. So that's it. Those are the basic modifications that I am expected to do with my code. Everything else remains to be a standard PAHO MQTT program. It's not different at all. So now let's run our button.py program, and this is going to send the state. Now this is 0 because the button is off. I'm going ahead and turning this on, right? And when we come back, this will become 1. Let's make sure this is shown in our dashboard. So we'll come back to the devices, and now there we go, button is glowing green. Perfect. So it's connected. This is the connection time and address. Let's look at the logs. Succeeded. I'm so happy to see this. I struggled initially because I didn't set the TLS authentication the right way, and the logs showed me a lot of errors. So it's nice to see some good messages like auth succeeded. It's positive. Now we come to recent events, and here you'll see button on off messages. Perfecto. That's all we want at this point. All right. Now the last step, let's go ahead and configure the bulb. And for this, I need to SSH into my other Raspberry Pi. This is the IP address. Okay, and All I got to do is open bulb.py and repeat the steps. So this is the org ID. Let me grab this. Okay, and I need to update my client ID as well. If you miss anything, you're going to see a lot of errors because the device cannot make a connection. And finally, you got to get the token for the bulb. Okay, and put it here. All right. So now everything is perfect. And if you notice, we're actually not seeing event here, IoT2/CMD, unlike the temperature sensor and button, where we actually published an event to this endpoint, to this topic. We're actually subscribed to a command, and there we're actually seeing state. So this is a subscriber to the MQTT topic. It is not going to send any data, any state. So we are subscribing. And if you look at the code, it's pretty straightforward. We connect to IBM Watson platform. We subscribe to the topic, which is the IoT2/CMD/whatever. And then on connect, there is a callback. On message, there is a callback. Loop forever will make the client listen continuously for new messages published on the topic. And when the topic comes up, and when the button state is on, go ahead and turn the LED on by sending a 1 to the LED. And if it is not on, then obviously we switch off the LED, right? That's it. Very straightforward. We are subscribing instead of publishing. That's the only difference. All the other steps remain the same. Now let me go ahead and run Python bulb.py. It's connected, but guess what? It is not going to really, it's not going to show us anything, right? Even if I turn on and turn off you can't unfortunately hear the tick, but it's actually a toggle button, right? So the bulb is not operating. So what's wrong? Well, this is where I want to introduce you to the concept of creating an app. So in IBM Watson, the concepts are slightly different when compared to the normal MQTT broker. A device that is like a bulb, an actuator, cannot directly receive commands. You need to create an app that is going to control the actuator or the bulb. That means devices can only publish and applications can only send commands. That means in our case, the button is sending the state, so it can publish. Temperature sensor is also publishing some data, so it can actually do that. But guess what? The bulb is actually receiving a command, and command cannot be sent by another device. And this is for security reason. So if I hack one of my Raspberry Pis, I should be able to switch on and switch off every other Raspberry Pi in my network, which is not ideal. So instead, IBM created a model where you need to create an app and only the application can send commands. That means it can publish messages to the topic that is ending with CMD for the bulb to operate. So now we need to create an app, and this app is going to sit in between our button and bulb. It will perform some authentication, and it will make sure that no one else is operating our bulb. So let's go ahead and create an app. But for that, we need to generate what is called as an API key. So when we come to apps, you'll actually notice that there is something called generate API key. So I click on this. It's a standard application. It automatically shows us the authentication token. So let's grab this. We need this for the app to talk to our device. So now I have one more key, and this is going to be the app key. And this is the token. This is the actual, it's like the username equivalent, the API key. So let's also grab this. We need both of them to, so this is the secret and this is actually the token. So we need both. Now I want to show you the actual app that is responsible for making the connection between the button and bulb. So here we need to update a few things, right? So let's make sure the app works, and then I'll come back and do a code walkthrough. So this is actually using a custom Python module called IBM IoTF. So you obviously need to do a pip install. I will finish all these steps and create a tutorial and publish it on LinkedIn. You'll actually receive a follow-up email from me after the article goes live in a couple of days. So don't worry if you don't understand this. There will be a very detailed step-by-step tutorial that will be published, which is exactly the same steps that I'm showing here. So we need to make sure that the application also has access to the same application, the same workspace. So this is the auth ID. This is an arbitrary value, app1, and we are using the auth method API key. So auth key is what we grabbed in the previous step. This is the auth key. And we also need an auth token, which was visible only once, and we got it here. So let's put it here. That's it. So now we configured our app, and at a very high level, what it does is it basically receives the message from a source device type. So we are setting the source device type as buttons, source device ID as the button, source event as the button. What is the significance of this? Well, the button publishes the state to a topic called button, and that's what we are actually using here. And then the target device that we want to control belongs to the type bulbs, and the target device ID is actually called red bulb, but I think I just called this bulb. So let's use that. And then we go ahead and connect to the Watson IoT platform, and we'll say when the button state changes, invoke this method called button callback. And we are now subscribing to the device events of the source. That means every time the button is operated, the application gets a callback. And in the callback, we simply take the button state in this JSON payload, and we publish a command. The publish command method is available only if you are using it from the app. You cannot do it from any other device. So now it's time for me to run this app. So what I'll do is I'll actually stop everything, right? So let's stop our button, our bulb, and here we'll go ahead and launch, we'll go ahead and launch our app. And this app could be running effectively in the cloud, but for now, I'm actually running it on my local machine. This can be packaged as a Bluemix app and can be deployed in the cloud, but I'm skipping that step. So now the app is successfully connected to the platform. And what is the job of this app? It's actually the broker. It's the broker between the button and bulb. And it is more privileged, more secure, because it runs in a different context than the device. So no one can hack into one device and take control of your entire floor plan, right? So, so that is the advantage of making the app route these messages. So now let's go ahead and launch our button. This is going to send a 1 or 0. And let's launch the bulb, right? So now this will get connected, and after that, we'll actually see I guess I made a slight change to my device. Yeah. So this is not red bulb, it's actually just the bulb. So that's the reason why I was not seeing the messages flowing in. So now, there we go. So now the button is receiving the response off, right? Why? Because the mediator, which is the app, is actually sending that, okay? So now the button is receiving the command. This is 0, this is off, and app is also receiving off, okay? That's the reason why the LED is not glowing. Now the final moment where we actually test the entire workflow. So now I'm going to turn on my bulb. There we go, right? So drum roll. So this is the connected devices app. So you'll see 2 independent devices that are connected to the cloud, though they are sitting next to each other. Technically, it can work even if they are, one is running in Hong Kong, the other one is running in Sydney. They can still talk to each other because we have an app mediating that communication. And now when we come to the command line, The button is representing state 1. The bulb is receiving the command on, and it is mediated by our app. So if you come back to the portal, look at the devices, we'll actually see that both the bulb and button are connected. Bulb is constantly sending an on or off command that is intercepted by our app, and that is going to the bulb. And if you actually look at the state of the bulb, it should show us, you know, the current state. So this is the information that the bulb is receiving. So pretty straightforward. We don't have a lot of code to write, but this is just the beginning, right? So now finally, when you come to the boards and click on the device-centric analytics, this is a nice dashboard view. So it shows us that we have 3 devices that we configured: a temperature sensor, a button, and bulb belonging to these device types. You can click on this and go to the appropriate device section, and it actually shows you, you know, you select this and it will tell you what is going on with the device, right? This is the metadata. So it's a nice dashboard view of everything that we configured so far. If you have some rules, remember IoT is all about rules. Without a rule engine, IoT is not very powerful. And if you want to learn how to do it, stay tuned for my next session. You know, in the next session, we'll actually connect the temperature sensor to the bulb and control the color of the bulb based on the temperature and humidity. So it'll be a nice extension to what we have seen, and we'll also explore the data analytics part of it. Excellent. So I'm so glad that everything worked the way I wanted it, with no glitch at all. And it's time for me to come back to my slide deck. Okay, so let me check if there are any questions. So if you have questions, I'll be happy to respond. So there are quite a few, but before that, it's poll time, you know, like every time I do. So I want you to tell me what you felt about this webinar. So how relevant was the webinar content? Even if you're attending an IoT session for the first time, this should help you jumpstart your IoT development. So I appreciate all of you spending a minute on participating in the poll. This is very, very important for me to fine tune my content and to bring you more customized, more relevant content. So I only see 70% of you voting. I appreciate if everyone participates in this. All right. Thank you. 90% of you voted this to be very relevant. I really appreciate that. And one final poll, which is a straight reflection of my delivery skills, the content that I created, and how I basically delivered the experience. So appreciate if you can, again, take time and tell me how you felt about attending this. Only 70% of you participated. I want all of you to tell me your feedback, your experience of attending this. Excellent. So I'm so glad that you like this, and stay tuned for my upcoming sessions where I will walk you through some of the advanced topics of Internet of Things. All right. So that brings us to the end of this, but at the same time, I want to spend some time on the question and answers. Slides will be shared, video will be uploaded, tutorial will be published, and once everything goes live, all of you will receive a follow-up email from me, from my mail ID. It is not going to be from anyone else. I will send you a follow-up email with all the links. So how did Raspberry device communicate? How did Raspberry device connect to IBM Watson? Well, it is using MQTT. As I mentioned earlier, it is a straight usage of MQTT with the credentials that we got from Watson. So if you are familiar with MQTT, you can pretty easily get started. What is the hardware you used with Raspberry Pi? As I mentioned, the hardware that you see here is actually called as the Grove Pi. It just avoids using a breadboard and makes it easy to connect the LEDs, the sensors, the switches, and all of that. So it gives you a nice plug and play interface to Raspberry Pi. It's called Grove Pi. You can get that on Amazon.in or any of the electronic sites. So is IBM Watson like a server that runs on AWS or Azure? No, IBM Watson is not a server, it is a service. That means you'll never have to provision a server, but you can directly onboard devices and use it like a managed service. So it is not really a server, but it is a service with an API endpoint. Where are we running app.py? At this point on my local machine. But as I mentioned, it's very easy for you to package it as a Cloud Foundry application and run it on IBM Cloud. You don't need to run it on your local machine. Is this specific to Watson? Well, not exactly. If you notice, I'm using standard MQTT terminology and MQTT libraries for the devices, and only for the app that I built, I'm using Watson specific APIs. Otherwise, this is a very straightforward MQTT program. Great. Can you share the hardware info with required connectivity? That's going to be a part of the tutorial that I'm going to publish. That should help you. Actually, I'll put a link to GrowPy Plus. You can go ahead and order that. Excellent. Thanks once again for attending. I really appreciate some of you attend all my sessions. I thank you, all of you, for coming back and encouraging me. Stay tuned for my upcoming sessions on containers, IoT, and microservices. All my sessions will be interactive, demo driven, and I hope you found them relevant. So thanks once again, and I'll see you in my next webinar.